Fyrir hönd Jónsson, fyrir okkur velkomin. Til þessar kynningar á dreifirstöðvum og millispennubúnaði, millispennurofum, Safe Ring og Safe Plus og svona tengdubúnaði. Það gerst mikið í þessari hönnun og byggingu þessara stöðva í gegnum árin hjá ABB. Þeir hafa hönnunin hefur breyst í gegnum tíðina. Þeir hafa hlustað á ábendingar frá viðskiptavinunum, okkur, gert þær breytingar sem þurfti að gera til batnaðar til að gera þetta enn betur úr garði. Þá aðalega við að tala þessar íslensku aðstæður okkar, veðurfarslega séð, tæringarlega séð og svona í heildina betri búna heldur en var hér áður fyrir. Þannig að það hefur gerst heilmikið í þessu og þeir eru tilbúin að hlusta á ábendingar og bregðast við þeim og hafa gert það og við munum gera það áfram. Eða þetta betrunarbæti eitthvað, þá erum tilbúin að gera það. Þannig að þeir eru svona flexible í því, eða svona sveigjanlegir í því. Og þessi kynning verður í 2 hlutum. Þetta svona cirka bát 2 sinnum 45 mínútur og það verður byrjað á stöðvunum sjálfum, farið í gegnum það. Síðan verður smá hlé og við förum hérna út og förum hérna niður og skoðum stöð sem hérna fyrir utan. Nú eru svo mörg að ég veit ekki hvort við náum hvort allir geti náð því í hléðin að skoða þessa stöð eða farið í gegnum það sem að menn við að sjá eða spyrjum eða annað. En þá verðum við hérna yfir daginn og það þá hægt að skoða hann eða spyrja eða fá upplýsingar þá seinna í dag eða eftir fyrirlestinn. Þannig að við gerum ráð fyrir að vera búnir svona hálf 1 með því eða öllu saman. Og síðan eru menn hérna hjá okkur sem eru sérfræðingar í tengdum búnaði eins og þeir eru liðavendinni. Það er einn maður hérna frá liðavend frá ABB Substation, Finnlandi, sem heitir Mika Kúkóla. Hann verður hérna niðri í dag, þannig að það er að nálgast hann. Þið talið það bara um mig, Vali eða Guðna er. Hann verður hérna ef að getur þá veitt ykkur upplýsingar við eitthvað spurningar yfir. Sjáum þau liðavend og annað. Síðan verður annar hérna frá Capitón og er hérna í dag, sem heitir Pítur Andersson. Og ef það er eitthvað í samtíð tengibúna, Capitón-búna, þá verður hann líka hérna allan dag og þið talið það bara við okkur ef að þetta benda ykkur á hvar hann er í húsinu. Nú, fyrir þess að 2 fyrirlestrar eru staddir hjá okkur frá Skíen, Ásgeir Gengnidal. Hann mun fara yfir seinni hlutann, sem sagt rofabúnaði, ABB Safe Plus og Safe Ring, tengdabúnað. Og síðan er Kynning Mandal, hann mun fara yfir stöðvarnar. Og þetta verður á ensku og það er sjálfsagt að spyrja og stoppa meðan menn að tala, þetta sé gangi best þannig ef menn hafa eitthvað spurningar. Það er bara rétt upp hendi eða kalla spurningar fram, bara jafnóðum. Þannig að Ásgeir ætlar að byrja með mjög stutta svona aðheiðakynningu, síðan tekur Kenneth við með stöðvarnar, síðan verður hlé og svo kemur Ásgeir aftur eftir hlé með rofabúnaði. Þannig að
Thank you very much, Oscar. My name is Oscar. As you said, I will start the presentation. Firstly, thank you very much for inviting us, Kenneth and myself, to Iceland. We appreciate very much to come here to meet you all and to have the opportunity to present Safe Ring, Safe Plus, the switchgear, and also the compact substations. Before we jump into the compact substations, I tell you a little bit about the factory and where we are located. Kenneth and I, we work on this red spot, which is Skien, south of Oslo in Telemark, 2 hours drive from Oslo. Skien is in ABB world, a key point. And that's why we are in red. Because Skien is in ABB the global responsibility for ring main units. So Skien is more than a factory. In Skien, ABB has R&D department. We work very close with all the other research centers in ABB and test laboratories in ABB. We have a staff of 40 engineers, and then we have the production, and then we have Kenneth and myself who work with switchgears and compact substations. This is the factory in Skien. This is where the medium voltage switchgears and the compact substations are produced. We are 350 people working here. They have built, we also developed, they have also a factory set up in China and in India for the same product. But every design, all technology, all tests is controlled and determined at ABB in Skien. And our company history. We have a long history with Brown Boveri, Norwegian Electric Brown Boveri. And this started in 1932. And for many, many, many years here, Skien was very linked to Switzerland in technology. You know, we have a lot of hydroelectricity in Norway, and Brown Boveri was one of the partners we had at that time. So we over these years, we made air-insulated switches, NAL, and then we had some epoxy switches, but in 1985 we stepped into SF6 technology. And the first switchgear, I'm sure that some of you know them, they were called RDC. We used to produce RDC, and then we stepped into Ring, Plus in 2000, and now we have 28 years of experience with compact insulated switchgear with SF6 gas. So this is the key business in Skien. SF6 medium voltage switchgear, 12 kilovolt, 24 kilovolt, 36 kilovolt. SF6 insulated. And this is the history where you can see how it started, and it grew bigger, and 36 kilovolt. And this year also we presented at the Hannover Fair a new vacuum circuit breaker, which is capable to switch 25 kiloamp for 12 kV, and it's also with automatic recycle. I will come back to that later on this afternoon. Here you see with whom ABB cooperates. ABB in Norway has in Iceland its partner Johan Rønning, and Johan Rønning is a very successful ABB partner. I have visited a lot of these red dots, but I think this one in parts of ABB products, Johan Rønning is extremely technical, have the very good knowledge, and they cover the complete range. ABB Skien, we work with Germany, we get Germany and Italy and Switzerland. To develop a product, it's more than just to design it. We have access to research lab, and when we develop a product, we start with research centers where ABB have mainly those who have done a PhD in physics and maybe have a master in mathematics to do modulation for us, to do electromagnetic fields, to do thermodynamic, and then we go on to use the network of laboratory in ABB, and then we build prototype. And when this prototype is built in Norway, and sometimes we test it in the Netherlands, in Ratingen, in Switzerland, or also we have a small lab in Norway. And then it's released for production. Everything what we produce here, Iceland has access to as a partner. So a little fact about the factory. We produce switchgear, roughly 110 million euro, roughly 350 employees, and export is more than 80%. Our core business is in distribution network from 10 kilovolt up to 36 kilovolt. And by having focus on one product, we can make the production efficient with high number of parts and standardized production methods, which is important to stay competitive in Europe in a very competitive and global markets. So by this modern factory, we have targets with on-time deliveries, which is a key point for ABB in Skien. Also, this was mentioned with this close relationship with R&D in Switzerland and Zurich. This helps us when we develop new products for the European market. And I will come back to one of the latest product we have, 36 kilovolts. But for the domestic markets, it's the most important market for the factory is Norway, and they have compact substations. Norway is very much like the Icelandic market. We have both switchgears and compact substations. I will continue with the compact switchgear after what Oscar said, after the break we have. But now I give the microphone to Kenneth. He will then guide you through the range of compact substations.
Okay, can everyone hear me? Okay. My voice is a little bit, I got some cold here, so I hope everyone can hear me loud and clear. My name is Kenneth Mandal, and I'm the product manager for CSS in Skien. Let's talk a little bit of the business concept for our substation. When we wanted to develop this product, we wanted to adapt to the Norwegian condition. And it's a lot like the Icelandic condition, at least in North Norway, we got the same conditions. We got three main elements that we focus on, and that's, of course, number one, safety for the operators and the operator, and reliability for the customers, and of course, this clean environment for our surroundings. That's our slogan. Some general information here. ABB substation are built on frame construction. That means that the bearing part is a framework, where the wall element and door are fitted into. Oscar, do you want to show this picture?
This one?
Yes. This framework picture. Yeah, as you can see here, all the substation, we got the product portfolio contains 3 different substation types. So this is the Magnum one we're going to show later, and this is the framework, as I talked about. This is the bottom frame, top frame, and the corners and sides. So after they've done the framework, they put in the wall elements and the doors. Okay. And of course, it makes a robust and stable building. The roofing solution has an integrated air and arc channel as well. That ensures maximum cooling of the transformer and safety by any arc inside the substation. The roof has a pitch about 20 degrees and very easy to lift off and off. It's just 2 bolts and you can lift the whole substation with 4 points on the substation with the switchgear inside maybe a transformer if it's small enough, and also the low voltage side. And the foundation you see, if everyone could see this foundation on the bottom side, it's manufactured in marine grade aluminium. This material is also used in floating docks and sea areas and unaffected by the outdoor settings. So the environmental aspects, in ABB substation we use 100% recyclable materials. That means it's metal. We are not using plastic, for example, for the roof or for the transformer tub. We have some which are doing that, but then it's not recyclable, and it can get really, if it's fire occurs in the substation, it will burn out. The medium voltage switchgear with arc suppressor prevents that the gas tank opens up and emit gases that pollute the environment. That's something else I'm going to tell you about a little bit later. But that's something we suggest for a customer, is arc suppressor. Personal safety, of course. I think this is the most important thing. We have tested according to IEC 62, 271, 202, internal arc classification A and B. That means 2 tests, 21 kiloamps for 1 second. I'm going to show you that a little bit later on the slides, but we have done the testing and filmed with a high-speed camera what happened with the substation. We also have this protection against contact. That means 2 barriers. You have to pass 2 barriers to come to live parts. That means a door and paraffin boom, or a door and cover for the live parts also, and also for the low voltage part. You have to go to the door, and of course it's a boom there as well. Yeah, it's a little bit more of the arc suppressor here. I think Asger will take that arc suppressor thing because you have some pictures there. Reliability. Ensure that the CSS has maximum uptime without any shutdown due to internal errors. Fully insulated low voltage and medium voltage side, of course. We have separate rooms or separate spaces for the 2 different apparatus. Filter is very important, at least in north of Norway and Iceland as well, in the ventilations because of the contamination inside the station. Snow and so on. Monitoring of important technical components. That's of course very important as well. Asger is going to tell a little bit about the smart grid system later. Remote control with automation gives short downtime on the substation. And of course, utilizing components and equipment intended for the environment and temperatures that may occur. So that means that we're using only tested things to have in the substation. Everything is tested. More about the personal safety. The roofing solution, we have a unique air system. It's through the ventilation gaps at ground level. The ventilation will go through here and go up here. And of course, we have this filter we can put in here, both and here. And as you see here, it's also arc safety. Internal arc will occur. The valves on the arc or the ridge will blow up, and all the pressure will go up on the roof. So, Asger, should we watch the video? It's on the link there. This, if you take Control Shift S, and you can take replay because it's really fast. It's a high-speed camera. I think it's 36 frames per second. But this is the internal arc classification B. That means that means that the surrounding area around the substation is safe when its internal arc will occur. We have a Kan du bare ta den da?
Ja.
Turn it litt off. Yes.
I'll try it again.
Yes. This is just 1 second. 21 kiloamps. We have the door locked, and we have a fault inside the RMU, the switchgear, and full short circuit for 1 second. And you can see by the arc, this is not with the arc suppressor. So everything going to blow up here and go up in the roof. You see there, the roof is popping up. The B1 is with the door open. No, the A1 is with the door open. I don't have this video here.
I have A, E, I say A is for authorized personnel. That is the utility is coming there to switch. And B is for the public. If anyone should pass through this compact substation by coincidence, as you can see, they will be guided upwards, the hot gases. Okay, so I stop this.
Feel free to ask any questions during the session. Okay. Then we have our product portfolio. This is the Junior Plus. It's the smallest outdoor operated substation we have. It's up to 350 kVA transformer, and you can choose either if you want to have these wooden panels on in different types of color. This is actually Norwegian, so I hope you understand a little bit, but I can tell it. It's gray-white, red, green, brown, and also different solution on the roofing. And also here we have the different medium voltage apparatus. We have direct to the transformer. We have the safety, the fuse switch on the underdel.
Lower base frame.
Yeah. And we have fuse cassette, and also the safering switch gears that we mainly use in this also. We have low voltage, different kind of low voltage. With XLVM, we can fit 6 400 ampere fuse lists in this. And this is the pole-mounted substation, usually placed between two poles, a pole H or aim pole. Yes. And you can choose if you want to have it delivered with the transformer inside it or not. Okay. This is senior 5 and 6. Is also outdoor operated substation. There's the senior 5. It's max 500 kVA transformer, and the senior 6 is maximum 600 kVA transformer. And it also, some customers use this with this free-winding transformer as well, so you can have one 240 side for low voltage and one 450. And here we have also this, for the medium voltage, we have this alpha switch, and also this fuse under there. And also safe ring. We can fit safe ring up to 4 models there. Here we can fit 8 fuse lists up to 400. So it's a choice. You can also fit on the other side, so you can actually fit 16. And this is also delivered by on fundament and with draw 4 now. Okay, this is the largest substation we have in Skien. The exterior here is also there's different kind of colors. I'm going to talk a little bit more about the new color we have now. But technically we can have fit-in subs. The transformer power we can have in 50 to 2000 kVA. we don't deliver that much 2000 kV in Norway, but it's a little bit complicated because of it's really tall, so we need to be careful. This substation is from 2.5 meter to 5 meter, 5.5 meter. We have different kinds of variants on this building as well. You can have this extra L-room with an own door for people that don't have this certificate to go in. You can have fiber room if you want a fiber room on the other side with an own door as well. And also you can put it together as one as you want with this thread set.
Connection set.
Connection set, yes.
Yeah.
And also here we have a lot of different variation on this Zekring and same class as well. Customer specific solutions. And here we can, depends on the size of the substation, we can fit in a lot of low voltage fuse listers. So the standard we deliver is up to 1250. Then of course we have the 1600 outside here, and that's a little bit bigger, 450. Okay. Any questions?
It's only the length that changes.
The length that
same,
yes,
same width.
Yes.
This width is always the width of a truck. So all truck can take this width, and then you can extend it in this direction to a short, depending on the kVA of the transformer.
Yeah.
So the transformer is, for a small transformer, the transformer is connected on this way, or even if you have a big one, the 1600 or bigger, you have it in this length direction. So this is very, very flexible. And each compact substations delivered from the factory is unique for one certain customer.
Tailor-made.
Yeah.
Tailor-made, more or less.
Tailor-made,
Yeah.
by using the standard elements, the frame here. This is always a fixed length.
Yeah, you can see it here. This is 1 meter, and this is half meter, so it's fixed.
Is the frame then also aluminum, like you said?
Aluminum.
But
not the
structure.
Not the structure. That's don't talk about it a little bit later. It's alu-zinc. Alu-zinc. I can talk about it now, but because we have these corrosion classes. We upgraded the corrosion class in this alu-zinc to C4. From C3 to C4. That was done last year. Okay, some news here. Low voltage connection, 4-pole short circuit safe cable clamps up to 2500 amps. Painted exterior. Of course, we have this. All the substation we deliver now, we can deliver with painted walls as well, not this wooden cladding. And we have some called forced cooling. Mining can be delivered with this forced cooling if the transformer is really loaded. AMM room, that means advanced metering management. This is a topic that comes up in Norway very much now. It's kind of a room that the customer wants to have to read out the metering for those day customer again. So I don't know if it's anything of that in Iceland now, but it's a
Not yet, at least.
okay, this is the low voltage connection we have now, because we usually don't deliver these cable clamps to the low voltage. So this is tested, short circuit proof tested at our short circuit laboratory in Skien, 50 kiloamps and 100 K peak. This is tested because of we're going to test this strength of these clamps. So you can have 1 parallel cable, 2, 3, and 4 parallel. So what we tested on our short circuit laboratory was this with 4 out 16 cables, 240 square millimeters. What was important was the distance between the clamping, because if you have further distance, the cable will go really high out, far out from each other, and makes a good strain on these clamps. So if you can see this, I can't even see it as well, but for the kiloamps, we suggest 60 centimeters between these clamps, and 50 kA, we suggest 50 centimeters between these clamps. Did we watch this? This is also filmed with a high-speed camera, so I don't know. This is tested with 50 kiloamps for 3 seconds. So it's a little bit long video, but we can see. I don't know. I don't think everyone can see very good because the resolution is not that good on this. But yeah.
Okay, we can play it. We can repeat it.
You don't need to repeat it because it's okay. You can see now the cables are going opposite direction of each other. There. And this is 16 cables with full short circuit on this side, and the load is the load is going in there. So this is just to test this cable clamp, see if it can keep up with this current. Yeah, you can see this clamp a little bit, but it passed the test, so yeah. This is Magnum 250 with this cable clamps mounted. We can mount them. We have brackets that we can mount it directly to the transformer, and of course on the wall we have wall brackets for walls. So this is a short distance. What's important that you have every cable in the same phase. If you got 2, 3, 4 pairs of cable, the distance of the cable should be the same for each phase. Okay, here's the new Magnum, which are painted steel. A lot of customers have bought this in Norway because of where they placed the substation. I think it's a little more strength in this substation because of it's painted. The thing that is really seems to be a problem is the handling. When it goes from our factory to the customer, you might, if you get any scrap or what they call EP, scratches, yes, scratches on this, it's not very good. So it needs to be handled with care. So this is the Magnum painted. We only have one color for now. This is green and gray. And we also have this on this senior. It's the same layout with kind of wooden-like printings. And also,
What kind of wood do you use?
Sorry?
What kind of wood do you use?
Oh, this is not wood.
What type?
Furu.
Pine.
Pine?
Yeah, I think it's pine. Yeah.
It's
impregnated and it's painted. You know, to a compact in Norway, most of the buildings are built with wood. And if you go up in the mountains, they are more normally dark. And if you go to more where the farmers are, they are normally red. So that's why we have these different colors to fit into the, let's say, most typical Norwegian architecture. And we have the neutral, which fits in all over, and the green, which is also fits in all over, and the white one, which we think also is a very nice Nice. So we have a few selections, but they're all the same wooden material, impregnated and painted. Yes.
Okay. This is the some information about ventilation and cooling for a substation. In case of the substation produce a lot of heat, that means that if you overload the transformer with more than 12 kV, you should have some forced ventilation on it, because the natural ventilation for a substation here is 12 kV. And that means the transformer with total loss, idle plus load loss over 12 kV with 100% load will rise up more than 55 degrees inside the substation, because the substation will give, no, the transformer will give heat to the walls, and the walls will give heat reflect back. So it's not very good. We have some cases in Norway. In the winter time, when there's a lot of snow, the substation, it's all clean outside for 2 meters or something because of this. So we had to do something there, and then we had this forced cooling. If you can see here, this is a wall element you can put next to the transformer here. If you can, okay, let me do it there. This is a wall element you can put in later. All you need to buy is this wall element, this fan, and this control unit for this. So we have delivered a lot of this in Norway. As you can see, it's a little bit angle on it, so usually fits all the substation as well. And you can either have 1 or 2 in both wall elements on the back. And this is also, of course, locked from inside the substation. The heat will then rise up, and the fan will force it down there and out on these ventilation gaps. So this one we delivered to Norway is like start the heat. The fan starts at 35 degrees, and at 100%. Now 45 degrees, it's at 100%. And maybe the other fan start at 30, and at 100% is 40 degrees. So this is a solution, but maybe it's not very relevant here because it's really cold. So yeah. So this is how it looks like from top view. This is the 2 fans, and you can, if you don't have any fans there, you can just put it in after. So, or we can install it back in Norway, no problem. So this is how it looks like from the top view. Okay, we also have this what the customer in Norway wanted, this AMS solution, or AMM. They wanted a door that people that don't have this certificate can go in and read out the metering for the low voltage, and also for the customer, which these low voltage are attached to. So on this junior substation, we have this door-in-door solution. Also, this is the low voltage cabinet, and then you have one cabinet for this AMM solution. This also we can deliver after it's bought, so it shouldn't be a problem to switch it out, because the customer didn't want to have this cabinet outside of the substation. We want to integrate it. So this we have to do. And also this senior have also this solution, but have some more solution here. We can also have it on, if the switch gear is here and the low voltage is there, you can have this cabinet here. If you have a low voltage here as well, you can have it here in the transfer room. Okay. among them, we have this room available. I had it for a long time now, and this is how it looks like in front. We have sold a couple of those to Iceland as well. From the top here, we have this room here with the own lock. You can also adjust this, so it's this is basically 300 millimeters depth, but we can have 600 millimeter depth if you wanted that. This is a solution that's an air plug.
Þessar upp á velli, þessar hái sveitur með þessar upp á velli, það svona, þarna sjáum við þetta auka rými hérna með sérhlug velli. Það kan merkja með sér þá.
Það er þannig fyrir götuljósspurningar að slitna frá veitunum yfir til sveitarfélagana, þá er þetta að vera með götuljósa stýringan og kontrollið í svona sérhóli, þá er það bara sérhóli og þeir komast þá ekkert inn í háspenningu.
Ja, ljóslega búnaði það sem
Ja. Okay, we have also options. Totally insulate the whole substation with steel wool and also plates outside, and then it's totally fire safe. We sell that a lot if you just switch gears in it, no transformers, and also if there's a lot of what do you call it, automation things in it, which are really well, for the environment, it's or conditions, you need to have this totally isolated as well. And then it's nothing will come into the substation. We also have a few other options with this PB room we have sold in Norway. If a customer wants also delivering the fiber net, you have maybe the high voltage the high voltage in this side, and then you can have a door on the other side with a total isolated room as well, with these fiber racks and a fan. So I don't have any picture of that, but we have sold a lot of this to the North Norway, where the utilities are both delivering the low voltage and the fibers. Og så på tida, Asgeir.
Ja, men det går rett der.
Okay. Okay.
Jeg kunne tenke meg at vi bare viste den der med sirkulasjonen med innstikksikkert.
Yes.
Så da kan vi, hvis vi finner den, så skal jeg bare fortelle litt på det.
This one. Okay, also this, of course, these ventilation gaps on the bottom level here have a ingress protection called IP4X. So that means nothing less than 1 square millimeter can penetrate it, go inside. Yes.
In Norwegian we call this innstikksikkert. I think you maybe understand this word, innstikksikkert. One key element for success of this substation is our former colleague, Asbjørn Heimdal. He dedicated most of his, or half of his career in ABB to optimize this compact substation. When you go to Europe, you will see that many suppliers in Europe, they build in concrete. I've been visit many of them in Germany, Betonbau, and yeah, it's a lot of them, but they have flat roof. In our design, we use the heat to circulate in the station. It's much easier to control the environmental when you have a circulation of air. If you make a flat roof, you can have droplets on the switchgear and on the low voltage part. Our angle here, this one is 20 degrees. By having 20 degrees, all the droplets, they will go to the side. They will go to this and or to that. And they will come down here, and they will not damage the switchgear. And also you have the cold air coming in, goes up, and it will escape here. In case there is a failure inside, this belufting, luftluke. In English, this will be ventilation. Is also the weakest point. So if there is a failure inside, this will open, and the hot gases escape. I've seen competitors of us in Germany and in let's say in Central Europe, where they try to build in different design. Then they need to have very lots of let's say simulations to guide the hot gases. It's very complicated then with the duct and ventilation downwards or backwards. So this one is very unique. It's reliable. It's used in Norway and now also on Iceland. And we see also in Sweden they use the same principle of design. We have delivered very few to, let's say, to Central Europe. One advantage is they needed to go with helicopter. And of course, with the beton station, it's so heavy they couldn't lift it with the helicopter. So in the Switzerland, we deliver a few, and also if you come to Norway and in the factory, we have many of the visitors. They like it because it's look nice. It's fit into the landscape. So we have also sold some for special areas where they like this design to be integrated in the scenery. Because we are very flexible with the colors we can offer you and the lengths. And our colleague Asbjørn, he dedicated the last 15 years of his career only to look on these small details, to optimize the angle here, the winkel, to ensure the high quality and the efficiency of when it was in service.
Okay.
Yeah. So, yeah. Yeah.
Any question?
Engar spurningar. Þetta allt liggur að hljóst fyrir.
Yeah. The price.
It's very good. Very attractive price. Very attractive.
Not a popular question. Competitive.
Very competitive. En hérna, nú ætlum við að taka pásu. Og við erum hérna með 2 stöðvar. Einu hérna inni, sem er 800 kW stöð. Við erum ekki með spenn inn í, svo erum við hérna úti með 1600 kW stöð, þar sem spenn er inn og þar sem við líka búin að vera með sínum svona af þá tengingum, lágspennutengingunum, 400 V tengingunum, inn á þann hlutan, einangrað allt og svo klemmur annað. Við erum yfir 40 manns hérna, þannig að við ætlum að skipta þessu í svona 2 hópa. Annar hópurinn, svona helmingurinn af salnum þegar þá byrjar að skoða hérna úti og þeir verða þá á sitt hvorum staðnum, sérfræðingarnir okkar, og við ætlum að taka svona hálftíma í þetta.
Thank you. Now we continue with the switchgears. I have a presentation, but also a new picture of some new solutions which we have. I start with first with the basic design. I don't know if maybe for some of you this is also a new topic, but Skien, we make switchgear for distribution of energy. And firstly is the development, which is a key issue, and the IEC norm. Our switchgear, I think we had a small talk in this break. Our switchgear is designed according to ESC classification. So for America, ANSI, this is not ANSI qualified. This IEC classification is valid for Europe, but also in Asia with some special GB standard. This for the Chinese, GOST for Russia, and EDF for the French market, and DIN VDE for the German markets. Our switchgear is, you could say, it's we have worked for many years. We've had frame agreement with EDF, Électricité de France. We have currently big frame agreements with some of the biggest utilities in Germany, E.ON. So the IC with some adaptation to the local norm is that makes this one the most used in all Europe, no more and more in East Europe. Our target is distribution of energy. I think later on today you will have more for high voltage, but we are on the distribution level, and my presentation will be for 11, 12 kV, 22 kV, and up to 36 kilovolts. Safe ring, the product name Safe Ring is if you have a ring and you put a switchgear which will be safe, and then it was easy to put the name Safe Ring to it. And here you can see how you come in and out with the cable, and the transformer is then protected either by a fuse and or by a vacuum circuit breaker. Each of these switchgear types we make in a standard configuration. Cable transformer, and we call this with English notification CCF, and a four-way CCFF, where you have cable coming in, cable going out, and you go off to the transformer. This switch is a load break switch. And for the Safe Ring applications, you can see we have 1, 2, 3, 4 units which are standardized from the factory. And here you see some applications where they are used inside a small junior enclosure, or in windmill, and in this one is a beton station in Germany. This switch is a 3-position load break switch, where this one is connected, disconnected, earthed. 1, 2, 3. That's what we call 3-position load break switch. And in the case of a fuse, you have the same switch, connected, disconnected, earthed. And for personal safety, when you earth it, both sides of the fuse is earthed. So this is available in 3, 4, 4, and 2-way units. Here you can see the notification. C for cable, F for fuse, DE, direct incoming, the E with earth possibility. So it's very, let's say, logic method that we describe our switchgear. We have also the same where you can use a vacuum circuit breaker instead of a fuse. You can use a vacuum circuit breaker with an electronic relay with pickup of current here with the CTs. Then you feed the relay and you open the breaker. This is if you have a high, from 1600 kVA, we recommend to use a vacuum circuit breaker. But also you will see that more and more relays are advanced, where you can have this also for self-powered relay. So this V is for the vacuum circuit breaker, and in here there's a vacuum bottle. Later on I made quite a lot of pictures from the factory so that you can see how this looks also inside. And this is the data label of the switchgear, the C and the F and the V. For the data label and for documentation, we have here a table with all documents. I have here 30 catalogs. If that's not sufficient, we can also send this by PDF file to you. So I think I will not use more time on the data labels that you can read there, or ask Kenneth or me if you have any questions. Safe Ring was the first unit, and then we extended it to be a Safe Plus. Safe Plus has wider application. It's used not only in utility, but also in industrial, for industrial purpose. And also for the last years, a lot of Safe Plus is for the windmill parks. And we deliver to mining and to fish factories. So, you see here that what we started off as a Safe Ring has now been a series of more than 10 cubicles you can select. You can select a cable switch, fuse switch disconnector, vacuum circuit breaker, and with a circuit breaker with a special drive, sectionalizer with vacuum, direct with earthing switch, oops, and bus earthing, metering panel, and a metering tariff panel, which is more for southern part of Europe. Now, the concept of the factory is that each single module is on itself type tested. This is like a Lego block system. You, our customers, can pick any module you like, and you can group them as you like, and you can design a switchgear according to your specific need. That's the idea about this Safe Plus concept. We know that maybe 70% of the need is still a Safe Ring, CCF or CCB, and this is available as a standard product from us. But we see increased tendency that customers select more and more advanced switchgears with new combinations. I mentioned this switch was this switch is with SF6 gas, so it's connected. You open in this one with the mechanism, and you earth it with the same mechanism, and everything is interlocked, mechanical interlocked. So there is a personal safety in this interlock. And that's with all the switches has mechanical interlock. And also for the fuse one, if the fuse is blown, you need to open, you need to earth in order to open the cover to remove the fuse. So for design criteria, safety, personal safety has been very important. The vacuum circuit breaker, this bottle is the same for all. It's called VG5. That's what they sell it as from Ratingen in Germany. And then we have the possibility to put up a relay on Iceland. I know you use a lot of this Ray 603 with the display, the self-powered. Yes.
The interlocking of the earthing switch.
Yes.
If the cable coming in is energized, is it mechanically or electrically? How is it done? Interlocking.
All interlockings are mechanical. But you mentioned an important point. What all switchgear what we deliver, let's say the hierarchy of the interlocking. The vacuum circuit breaker is interlocked with the disconnector. The disconnector is interlocked with the earth switch. This is always in our switchgear. In addition, you can ask us to also to interlock the cable covers with the earth switch. And then you need to earth in order to open this cover. But this you need to specify to Valur or to Asgeir that you like this cover to be interlocked. We can make this cover interlocked. But it will be mechanical interlocked. Yeah. I will show you some picture of the combi sensor later on. And this is a new, where we have a circuit breaker, even up to 1250 amp. It's used, we had a big project to Austria for a carton factory, cardboard factory, but it's not so much used in utility, this one. Almost never, but some special industrial applications. This drawing is what I will show you later, a drawing of what is inside the bushing. In this case, inside the bushing we can include a resistive divider and this spiral core, a Rogowski coil, which gives you a linear output of currency and voltage. That can be, this output will then later be used in a relay, which we'll come back to. Yeah.
I can see you have REF control and protection unit there. What do you use on the transformer modules? REF?
We normally use, no, we don't use so much REF, we use REF.
On the REF?
Yeah, that's the most standard in the factory. That's what we have. We can use other, but then it's we need to make the drawings and to buy the ref and the head relays from Finland. I think Valur that he will have a presentation later. This ref and red. But yes, it's possible to use other than what you find in our catalog. What limits it's mainly for us the space up here. Yeah, that's because we have a compact design. Yeah, and then I go quick through this other. You can disconnect the bus bars, and you can do it with the vacuum circuit breaker, and you can have a direct cable connections. This one is very much used for the wind towers. In order to save cost, they have just a direct connection and a fused or a vacuum circuit breaker TF. They are not so important about to connect all the ring, just to connect each single windmill to the grid. And these are all the basic building Lego blocks. In order to sell energy, I think it's the same in Iceland, you need to have class 0.2S. And the metering panel, we have a standard metering panel here where you have the CTs and the VTs. I will also show you some new pickups for voltage and current. But that will of course not have this accuracy, but we see a tendency that the more you add new green energy sources, which are normally small energy sources, the more you need to control the load flow in the network. And then you don't really need an expensive metering panel with a high class, but you can manage with the sensors, which I will show you on some of the pictures. This one is the standard metering panel is type tested, but we also have one where you can build in any VTs and CTs you like, but then it's not type tested from the factory. Inside it will look like this, where you have the 3-position switch on, off, earthed. And this, you see the bushing, the copper, and it's round copper, very geometrical, nice shape, in order to minimize the width and depth of the switchgear up to the breaker itself. So the braking is in SF6 gas. So SF6 in this case has two purposes: insulating media and braking media. Medium, braking medium. And this is when it's with the fuse canisters. Each canister is for a fuse 442 millimeters. For low voltage, you have for 12 kilovolt, you have a fuse adapter. So this is put inside this one. Here you see the fuse adapter, which you need to put on, and the striker pin to the front. In case of a vacuum circuit breaker, this is the vacuum chamber itself, which we buy from ABB in Ratingen. And this rotating shaft is linked to the mechanism in the front, and this is the disconnecting part. With this one, with the vacuum VG5 bottle, you always need a relay, electronic relay, either the self-powered or ref relay. This is what is most used in Iceland, and also not only in Iceland, but also in ABB. That's the self-powered relay. This is a VIC. It's used in Germany because it's a German design. And here are the ref relays. I think I will not spend too much time on this because you will have a separate lecture, or you can ask question about this later. Yeah. We have the ref man
Specialist here.
We have the specialist here. So but now we come to a device where I will also show you a small video. I mentioned that when we developed the switchgear, it has been two major criteria, and that is to keep it compact. The second is to personal safety. Or let's say the first is, of course, always personal safety, and then it's to make it compact. ABB made a patent. This is, I think, maybe 20 years ago, maybe 15 years. And at that time, it was Drische had the patent, ABB had the patent. ABB, we still, the patent is, a patent has a validity of 10 years or 15 years, so this is gone. But still, the concept here is unique. We have a separate device with a membrane, which is linked to a switch. And we call this arc suppressor. If there is a failure in the switchgear, the failure will be, let's say you stand in front of the switchgear, and the failure can be inside the SF6 compartment, or it can be in the cable compartment. If there is a failure inside the SF6, which are where the customers are most worried, we can build in this arc suppressor. This membrane will act very, very quick. In case of internal fault, this flash will generate heat, which will expand the air. The air expansion will act quick on this membrane, which trigger this latched spring, which hurts all incoming feeders. And in 30 milliseconds, there is everything is over, and this will not burst, or like we saw in the video from Kenneth. So if this was exploded inside, the smoke and the heat will open and go up to the top of our compact substation. But here, this will stay inside. We see an increased use of this one, request for this in Europe. And it's not, mainly it's for personal safety, but also it's for building safety. It was in Heidelberg. If you have been in Heidelberg, you know it's a very nice city, and they wanted to put this switchgear inside a very old, nice, was it Schloss? Palace. And then they could not hammer through the big walls to make a canal to the outside. So then they installed it with this one. And also we have this in some factories where there is a lot of people in the area, and in some really dense area where crowded area, crowded area, or special buildings. But also it gives in the compact substations also add additional safety. I will show you now a video how this works. Ja, ska vi se, så nå må jeg den. Så. First I'll show you some video of how it looks like in This is Kenneth talks about pre-carriage. So you see, this is the membrane, and you see this is the spring, and here you see 1, 2, 3, 4, 5, 6. So this will be for CCF. This will earth all the both incoming modules. Click on this. Yeah. So you see, it will be charged. The pressure will act on this, and this spring will then short circuit the bushings. And here you see it's short circuit directly on the rear side of the bushing. And now I'll show you the video of this. And then, ja, med video 1, tror jeg. This is if there is no arc suppressor. This is how it looks like. And now I'll show you with arc suppressor. Look at the cables here. Very, very big forces on the cable. No? So, and then we can take this one. So you see, that's the difference with and without. But still, the man standing in front, he is protected. Because you see, hot gases are guided backwards. And this one will stay inside the hose. In our case, you have overpressure, and this pressure must find a way out. And our solution is to guide it upwards. Normally there is no obstacle upwards, so that's always a good direction. But also this arc suppressor is extremely efficient solution. And this is available. You can install this in all incoming. The important thing is that where the energy can flow into the switchgear, into the substations, these modules must have such a suppressor. It can be the C module, the D, the DE, or the vacuum.
Okay, so in a more complex module combination,
yes,
it's the incoming feeders that should have.
Yes, all where the energy can flow into the switchgear, they must have this device. Exactly. So, for instance, the transformer the few switch modules, they don't need to have this.
So this should be ordered, not afterwards. It should be.
Yes, you need this must be, because I can show you some pictures of how it's installed. This must be ordered when you specify the switchgear.
Okay.
I can then go back to the pictures I had, photos.
But this is not a standard piece of equipment for all incoming fuels.
It's not a standard.
Standard.
No, it's an option.
It's an option.
It's an option.
This is an option. Now, what I'm telling here, that's what's possible for ABB. I'm not. The standard is. I can show you what the standard is. That is.
Then maybe
We'll show you
have a
the.
standard to have it and an option not to have it.
That could be right there.
The standard is actually a IAC, AFL classification. That is the standard. So IAC means internal arc classification, because in the past this was very, let's say, it was not standardized how to test a switchgear, but now this IEC norm made a rule. They say, firstly, internal arc classification, that is arc inside the switchgear. And you can ignite it in the inside the bus bar, but also in the cable compartment you can ignite. And then there is accessibility A and B. A is the operator in front. So if I should be the operator, I will be then 20 centimeters to the switchgear and operate. B is what is unrestricted accessibility for general public. This will be if this was in the middle of Reykjavik. Anyone can sit next to it and have a picnic or park their bike. So the switchgear is tested according to A, and the compact substations need to be tested according to B. Only authorized personnel are allowed to enter the switchgear and to switch. And then they define this front, which is of course easy to understand. Lateral is Latin, and it means just left or right, both sides. Lateral side. And rear side. In some cases, we also deliver rear, because most typical is a wind park, because in the windmill it's like 100 meters up, and it's circular, and they will not make any cutout for insulation due to the mechanical stability of the big tower. So for them, we put up a, let's say you go down, backwards, and then you can blow 100 meters up. So then it's safe in a wind park. But for a standard switchgear, it will be in our case, it will be IAC, AFL, and then it's followed by number 16 kiloamp, 1 sec. So then you are protected as an operator, and this is if you are the operator standing here, operating the switchgear, you are protected in the front and to both sides. I wanted to show you some pictures of some pictures of when we make this fault.
What is the price difference between this, let's say, the normal solution and this option solution?
Svona 8-9%.
Okay, I think now I will show you.
Á þeim módúl, skilur, sem hefur verið módúlinn þess að. En það, svo kannski feltið stærra, þá var það kannski 4% af öllu feltið.
Okay, I don't have so many minutes left, 10 minutes. I show you some pictures from how we make the switchgear. We start with a stainless steel tank, and we equip this one with, this is the switch, where you can see where it's earthed, disconnected, and connected. These switch gears will then be put into the, these are the vacuum circuit bottles. And they will then put into a rack. And this rack will be put into, and then the bushing. And the bushing is important, because on this bushing, there is a pickup point. Inside this bushing, we have a capacitor. And this capacitor is linked to another safety device, which is called the high resistant indicator. So there is one capacitor inside here and a second capacitor here. We have everything here is sealed with a coax cable, and we have a O-ring, and we connect this one to this point. And then it's, let's say, if you compare some French norm, it's called VPIS, voltage present indication system. It is a difference from VPIS versus VDS. ABB, we deliver VDS. They are both hot ohmic, high resistance, but voltage present indication system differ if the voltage is on, this will have a red light. But then you need to question, if there is no red light, what is then the status of the voltage? And then in this former French specification, if there is no red light, you can actually know for sure. So you should, in order to be 100%, you need the earth. That's what the norm says. With this one, VDS, you can be sure that is high voltage. This basic device has an output of 70 to 90 volt. In microamp, it's only like 2.7 microamp. And now there is a whole set of new indicators coming. This is the plug which seals it, and I think it's important, a small detail, but for Iceland you should also think of this small detail, because this one prevents humidity, sand, salt to come into the switchgear, and the switchgear should be personal safety for a lifetime, and you should expect more than 30 years. That's tested switchgears from us. And now we have some interesting devices with this bushing. As I mentioned very quick, we have this combi sensor. The combi sensor means that in this one we have a capacitive divider, and we have a Rogowski coil, and this one is, you can, with this green cable, you can take this plug, RJ45, and plug it into a ref relay, and then you can measure voltage and current linear with a ref relay. The accuracy is not 0.2s for the mid-wing, but with calibration you are 0.5. So it's very good and very compact. So one of this replaces then one VT and one CT. If you need to keep control over the load flow in the network. In addition, there is what they call instead of high resistance. This one is what we see now will. This is a high resistance system, and this is a low resistance. And with this low resistance, you can connect to devices which can also give you this one in combination with small smart boxes like this. You can put in combination, and you have you can measure not only short circuit but earth fault direction of short current, and you can even measure voltage and some other parameters I can show on the picture. And this will be, we will see that this will come more and more in the future, that some customers ask for this small, compact indicators. Now, I can show you the picture of these indicators. Firstly, we started off with, to make a special version of the manometer. We can have the manometer with the electrical contact. So then you will know on remote what is the status of the switchgear. Green or red, on, off. And then and then you see this one is the capacity voltage device. And then we use a compass B device. And now you can read off L1, L2, L3, you can read off the voltage. You can read the current. You can read cosinus phi and frequency and average every 15 minutes, maximum a day, 24 hours, maximum 7, current maximum 7 days, and year maximum 350 days, and maximum after last reset, and the voltage, and load flow direction. And this device you can build in with this low resistant metering, low resistive capacity voltage metering. At the moment, there are two suppliers from Germany which we use most, Kries or Horstmann. But I will not go deeper into this detail, because then you can have the catalog from Valder. But just to know, to tell you that this is possible to get. Also, I wanted to show you the unit we put to the Hannover Fair this year. Yes, this one. This is a CCV module. You have here. You have all the new items. I'll show you the manometer with electrical contact. We have here a capacity voltage pick a point from Kries or from Horstmann. This can be linked with the motor because we have the space inside the cubicle. We can put two batteries, 12-volt batteries, 20 amp hours. We can link that to a charger. So these two batteries now will run the motor. If you have, let's say, your main supply here, and you can use this capacitive device to measure if voltage is present. If the voltage disappear, both switches we can program a mini PLS with logic, so they will open. If one of them, and then you can, if this is the reserve, you can connect it, or you can have some logic. Let's say if this is the main supply and it fails, you connect to the reserve. Instead, if they both fail, you wait for whichever is coming back, and if one of them is coming back, you can have a time delay of 30 seconds, and then you can connect it. So this we see more and more as a factory that customer has unique specification for certain point in the network. Not all substations, but in particular where you have green energy coming fed into your network. This TOF is the new V module. This is a recloser. You need to charge it, and this can open, close, open. And everything now run by 2 batteries and with capacitive sensors. And this one, the new vacuum circuit breaker, you can have with a relay. Also the self-powered. So this is the newest, the latest technology from ABB in Skien. It's called VD4. This one is called, the name of this one. And for the bushings, you can have some sensor for current around the cable, or we can have them around the bushing. So this is how it looks like. You can also put a top entry box. One problem in Germany is that, and also in some European countries, is that they don't want to have to build in the city. They want to have small compact substations. They even put the substations halfway down in the ground. So we made also a small version. You see with the lower cable compartment. So the height now is reduced from 1.3 meters to 1.1 meter. With a lower height. I don't know if that is any need for that in Iceland, but on request, this is possible. So here you see the switchgear with the battery installed, with charger, with pickup on the capacitive device, with some logic, and then you can combine all this, and I think the last I have a small setup of this will be, and so I'm looking for smart kid. F5. So what with all these small devices? This is how we normally run the grid from top and with via hierarchy to the bottom. What we expect in the future is that the grid will be a mixture. Here you feed in green energy. There is a factory and a smart house. And the grid is much more complex in the future than it used to be. So you need to have more control over load flow directions, and you need to measure current, you need to measure voltage, but they will be too expensive to build, as I showed, this air-insulated metering cubicle, which in the past was designed to sell energy, not to monitor. So by using all these small devices I show you, you can actually then you can move in this direction, where you also have to charge in cars, for instance, which I know will be a topic tomorrow, so that you can guide flow direction and you can monitor flow direction. This was too much text. I dropped that. So you see that the basic package from ABB on the ciphering units, you can monitor. You can monitor voltage, you can monitor current. And then you have the second, that's the diagnostic. With all these smart small boxes, you can monitor, did I have a failure, an earth fault, direction, which direction. You can you can control it by this switch on, switch off. And the last one is the diagnostic, that you can also at the same time do to get the information about the status in your network. So we see a tendency to monitor, to want to remote control it, and to diagnostic. One important thing with the switchgear which is already delivered, you can, if you like, the front of the switchgear, you can easily remove all the front covers and you can take out the shaft and you can plug in a motor. You don't need a top box. All motors can be plugged in. Additional coils. And you can plug in, you can mount in batteries. So for the future, for assisting unit, you can upgrade the installed one to also to be able to be remote controlled. And then the important thing is of course where to pick up the voltage signal. That is the critical, the voltage signal, how to access the voltage signal. And that will be now for the future via the capacity voltage indicators. So I think, Valur, that was my time.
Yeah, if you're finished.
If you have, I have more photos. If you like, you can show from inside the switchgear. I have some video how the switching is done, but it depends a bit how much time. Or if any of you like to see that later, you can come and ask me, and then I'll show you it in the laptop. So now I follow your agenda.
I have one question.
Yeah.
You showed us you use ref relays
Yes.
from ABB, but in the transformer station downstairs, there's no ref. There's only pipe tipping protection.
Yes.
And that's cell power, but I know that. But if you use ref, do you need to have batteries and chargers? Or
You need to have power. You don't need to have battery. You can have, if you have 200 volts AC directly, that's why you need to have current voltage. Yeah, you need to have a power supply for the ref. There is only two suppliers who have this self-powered relay, and that is the ABB Ray and the German Schaltanlagen Elektronikgerät, VIC, which are self-powered.
And also the one we use for the Norwegian market.
Yeah, and then there is one we used in Norway, which is Scandinavian Electra, but that was outsourced to Spain. So there are three self-powered relays we know we can install.
One more question. The SF6 breakers.
Yeah.
You're monitoring the SF6. Is it in such a way that if there's a leakage and it comes to a certain level, you get a warning and further down it is blocked, or?
What we monitor the pressure.
Yeah.
Because the unit is filled with 1.4 bar. Huh?
Okay.
So all our equipment have a red-green manometer, and if you come
Is that a
to
warning or a blocking?
It's a warning.
No, it's a warning. It's a warning.
Okay.
You can only block it if you have the electrical and remote switchgear. Then you can put. Then you can of course get the warning, and you can also block the motors. But that is if it's remote operated via motors, and you use electrical contact in combination with the manometer.
Basically, the normal deliverance is
Warning.
a warning,
Yeah.
and if the leakage is, well, heavy, and you are not quick enough, it could fall, so there is no SF6 left.
Yes.
If you have a failure, what then? Is the breaker capable of how much percentage of the nominal breaking current?
If this will happen, what we recommend in Iceland is normally 12 kilovolts. We have done all type tests at 24. So of course you have a huge safety gap on Iceland. But still, if this indicator comes to red, what we say then, you should open on the neighbor stations. You should not switch the low break switch. In cases where you have a vacuum circuit breaker, the switching is done inside vacuum. So then you could operate the vacuum circuit breaker. But on Iceland, the line switch is SF6 insulated. And that's why we will say, as a supplier, you should not operate the switchgear. You should disconnect it, and you should phone ABB and tell us that there is a leakage. Yeah.
Altså hvis det er feil på en manometer, kan du også sånn at man skifter den?
Ja, å bytte et manometer er, maybe I have on the pictures. I have,
Björn vill tala norska då.
yeah. Maybe I have some photos here with the manometer. Yeah. Okay, it was not easy to see, but the manometer is connected to a kuleventil in Norwegian. I don't know the English word.
Það lokið fyrir innan, sko. Þetta mjög einfalt. Þú bara nokkuð nýtt og stundum.
Val.
Yeah, yeah, yeah.
Það einstaklega lokið fyrir aftan, hann lokar strax fyrir að leiða og opna.
Yeah. So actually,
Mjög einfalt.
yeah, what you take a
Wrench. Nipple
wrench, yeah, open it, take it out, and then immediately this one is tight due to this kule ventil. And then you can install a new manometer, and if you put this manometer at 11 o'clock, and then you tighten it, it comes to 12 o'clock, and it's in center, and that's it. So it's very easy to replace the manometer.
Putta hestlappa til 11 og svo líkill hálfum og upp í 12. Þetta tekur bara nokkra mínútur. Mjög einfalt.
Den viser trycket på tankarna, så den kommer från fabriken.
Then what?
Den manometern, den visar trycket på tanken alltså.
All units. This one is pointing at 1.4 bar. All units are filled. What we do, I think I have that on the picture actually. How we test it. I think I have that on the.
You said it over time, it could be some diffusion, it could be a little bit lower over time.
Yes.
Not because of leakage, but
Yeah.
because of
So you see, this is the unit. Here you see this cooler ventil. What we do, we put the whole unit inside a huge chamber, and then we make a vacuum inside. We make vacuum. The whole process takes about 20 minutes. When vacuum is achieved, then we fill via this ventil, we fill helium, and then we pump up helium. Helium molecules are much smaller than SF6 gas. So then we measure with electronic devices because they can sniff helium much easier than SF6. SF6 will stay on the sidewalls. It's more like water droplets. So helium, it's floating free around. We measure the helium over then for a certain time, if we have no diffusion, then we make new vacuum and then we fill it with SF6 gas with 1.4 bar. And then we put on the manometer. We say that this switchgear is sealed for life. But with overpressure, you can look at the switchgear. It looks like this. You can see at the top that it's curving. There is always a diffusion, but that is more on a molecular level. That some molecules manage to escape through even via this tight surface. We have measured this leakage, and we state that also in our catalog, and it's less than 0.1% per year, and we have calculated that even, the gas pressure, even if you reduce after 30 years with the reduction of the gas you lose, you will still pass all type tests. Actually, we did in Belgium, we did a test for this in Belgium. The Belgian authorities, Synergrid, if you check into www.synergrid.be, you can look into approved switchgears in the Belgium network. And they are called Laborilec, that's the laboratory. They asked us to deliver 8 units. And they heated all 8 units up to 40 degrees. And then they measured SF6 leakage. And which were small, but one which had most leakage, they took up the worst leakage and heated that up for another 2 days for 80 degrees. And then they did a calculation. And in the report we had back from them, it says that the leakage was based on the leakage, the lifetime is 78 years. But that was the diffusion leakage we have on the laboratory in Belgium. But we state there is more than just SF6 leakage. You have all the greasing, you have the mechanical drives. We state in our catalog that the lifetime is exceeding 30 years. In practical, that would be 30 to 40 years. SF6, if there is a leakage, that's a serious case. You should warn ABB. The first thing you should do is to check the manometer. You should see if there is a curve with the overpressure. If not, you should switch off, send the unit back to the factory, and we inspect it, and if possible, repair it. But we put a lot of energy into sophisticated filling, detecting system to ensure that the primary part is sealed for life, personal safe. Yeah.
Okay.
Yeah, okay.
Og ef þið vilja ræða við Ásgeir og Kenneth einhver svona dítelatriði fyrir fullt af upplýsingum og geta haldið áfram í allan dag, en fá það ekki. Þannig að við ætlum bara að ljúka sem við minna ykkur á að við erum með þetta glæsilega kaffihús hérna niðri. Þannig að við erum glætt með svangir núna eða svöng og bara býð ykkur hjartanlega velkomin að heimsækja okkur þar og setjast yfir kaffibollu og ræða málin áfram. Spennandi viðfangsefni sem við erum búin að vera í sýningu. En bara þakka ykkur kærlega fyrir komuna og vona að hafa eftir eitthvað notað.